Hey guys, welcome back to another video. This is Into the Knowledge and you're watching everything you should know about the black holes. Now, in this playlist, in this video, I'm going to tell you everything about the black holes, basic to the conceptual things. Everything will be covered in this video, and also this video is a part of the playlist everything you should know about the black hole. And if you haven't watched my previous video of massive stars, which is actually a compulsory video for watching before watching this video, so you can click that eye icon on the top right, and that eye icon will directly lead you to my previous video. Without wasting time, let's get started. Now, what are we going to study in this video is information about the black holes, and also some general queries should be answered, and also we're gonna ask ourselves that do they die or not, and also get the answers of it. So if you talk about the formation of the black hole, as I told you in my previous video, that at the death of the massive star, it creates a black hole. If you haven't watched that video, please watch that video first, because I've explained very briefly in that video that how and what happens in the massive star which creates a black hole. But in just a brief, I'm gonna tell you this in this video also. So what happens is, when a massive star comes to its death, at that time, the core and some parts of the mantle of the star collapse itself into its own gravity and forms a huge ball-like structure, which in turns to a black hole. And so a black hole is formed, obviously. Now, what is a black hole? One of the commonly asked question, what is a black hole? So black hole is one of the most mysterious thing in the night sky, and also this thing, the black hole, have so much capacity of its gravitational force that even light cannot pass through it. Like if there is some kind of light going through, or electromagnetic wave going through the black hole, then it can go inside it but can never come out because of the gravitation field of it. It's one of the most mysterious things. Like in this image also, the gases of that star is being taken from it and is revolving around the black hole. So this is a black hole, the very basic answer of what is black hole. Now, what is Schwarzschild radius? Before understanding other things, I'm going to tell you what is Schwarzschild radius, because of this thing we can understand about the black holes. So Schwarzschild radius is actually a kind of radius, if in which this radius is creates a sphere, and if in this sphere you contract, or anyone contracts a object inside it, then it would turn itself into a black hole. Obviously this radius is different for every object. So the formula for deriving the Schwarzschild radius is this: R is equal to 2gm upon c square, where R is the Schwarzschild radius, g is the gravitational constant, m is the mass of that object, and c square is meaning the light speed square, the speed of light square. So the mass, because of the mass of the object is different for every object, therefore the Schwarzschild radius is also different for the every object. Now what happens is, when mass increases, the Schwarzschild radius increases. When the mass decreases, the Schwarzschild radius decreases. This is the Schwarzschild radius chart, in which there are approximately 7 kind of things shown with their masses and Schwarzschild radius and density. So we are not dealing with the density right now. We are only dealing with the masses and Schwarzschild radius. So the Earth is having the mass of 6 into 10 to the power 27 grams, and this its Schwarzschild radius is 9 mm. That means if I take a sphere of 18 mm as a diameter, and if I collapse the Earth inside that sphere, then it would form a black hole. And here the sun, the mass of sun is 2 into 10 to the power 33 grams, and its Schwarzschild radius is 3 kilometers. That means we need to compress the sun to 3 kilometers as a radius of a sphere, and then it will turn into a black hole. Same happens with the galaxy. Galactic mass is approximately 10 into 11 times the mass of sun, and the Schwarzschild radius is 0 into 0.03 light years. So it's a very detailed information for you. If you want to read, you can directly read it. Now, there is not only one kind of black hole there in the night sky, there are three kinds of black holes. First, premodel black hole. This kind of black hole is created just after the starting of the time. That means when the universe was created after the Big Bang. Just after the Big Bang, these kinds of black holes were created. And the specific size of the black hole, that is the center part of the black hole, this, yeah, here, the center part, can you see that black spot there? This thing. So the size of this black hole is approximately of an atom. They are so small, and so they are known as premodel black holes and also the most ancient black holes. Now, stellar mass black holes are one of the most common black holes in the night sky. These are having the radii of 10 miles to 100 miles, and also they are one of the most common black holes we ever observe. So, also in the maximum number. The next comes is supermassive black holes. If you get to compress like approximately 20 to 30,000 suns in one ball, that is the size of the supermassive black hole. They are so huge, they are massive, and therefore they are named as supermassive black holes, and they are kind of rare. Not rare, but they are less than the stellar mass black holes. Now, the biggest question, or we can say another question of the black hole, what is in the center of the black hole? Like a very commonly asked question. So here is a representation of the space-time. This is a representation of the space-time, and this thing is the black hole. Here, this thing is the black hole, and here it is a singularity. So this singularity is the center of the black hole, and this thing represents the black hole in the space-time. Here, singularity is just a point kind of thing where the matter is unknown to us, the density is infinity because of the compression of that star, and also the gravity is also infinity because the density is infinity. The mass is like huge enough, approximately infinity. Therefore, singularity is just kind of point kind of thing which is having the density infinity. And so, this is the center of the black hole. Now, another question which is very common, that is, what is the center of the galaxy? What is in the center of the galaxy? Like in the Milky Way galaxy, if you just spot the center of the Milky Way galaxy, you can see a white light shining from there. And here, this is also an image of a galaxy. This is all. Here also you can see a white light shining from here. Now, what actually is this? Seriously telling, some theory says that in the center of the galaxy there is a supermassive black hole. Yeah, and that's the most like believable theory of all times. So we consider that in the center of the black hole there is, sorry, in the center of the galaxy there is a black hole. Now, the question then comes is, if there is a black hole in the center of the galaxy, why we are representing it with a shiny thing, or why can we see the shiny thing? First of all, no galaxy images that we see on internet is true, because we cannot click this image of the center of the galaxy. Why? Because of the galactic dust. Those dust block the pathway from the center of the galaxy, and so none of kind of probes, none of kind of anything, and none of kind of telescope can capture the image of the center of the galaxy. So all these images are artistic images. Now what happens is, this center is considered to be a black hole, but this also have a very shining thing. The reason is here. Consider this is a black hole, and if I leave a pen kind of thing, it will start rotating towards it or around it until and unless it goes inside it. Now, same happens here. This thing, this black hole actually attracts object around it, but that object starts rotating around it before entering inside the black hole. It seems happens in the solar system. The sun tries to attract the planets towards it, and the planets try to rotate around the sun. Same happens with the black hole. And so due to the high energy, due to the high friction between the particles, due to the light rotating around it, this black hole doesn't release light, but the acceleration disk, which is the disk around it due to the particles rotating around it, releases light, which we can see in the center of the galaxy. And this light is representing the center of the galaxy, nothing more. So the acceleration disk actually is a thing which releases the light. Now, one of the most commonly asked question again, what if we jump inside the black hole? Sorry for this is, what if we jump inside the black hole? What happens is, many of you will answer that if we jump inside a black hole, we'll obviously die. Why? We don't know. Whenever we jump inside the black hole, we'll also teleport it to another universe. This is also theory. Well, this might be true, might not, maybe not. And another theory is that whenever we jump inside the black hole, we'll contract ourselves because of the gravity and will be the part of the core of the black hole. Well, I'm not supporting any kind of the answer here because this is the reality. When you try to enter the black hole, if you are standing and entering the black hole, that time the gravitational field acting on your leg and the gravitational field acting on your head, they are two different things. That means the difference of the gravity acting on your leg and acting on your head is that huge that your body will start elongating itself. And due to this, when your body starts elongating yourself, you'll look like this, and obviously it would kill you. And so before entering in the black hole, a person, a probe will die or will be destroyed. And so we cannot just enter inside a black hole. Now, black holes in space-time. The representation of black hole in space-time is like this. If we represent sun in the space-time, it looks like this. It wraps the space-time a little bit, not more than anything. Then it if we put a neutron star in the black hole, sorry, in the space-time, it would wrap the space-time like this. And I'm telling you, more it would wrap, higher would be the gravitational force. So here the gravitational force is almost like approximately infinity. And if we put the black hole inside the space-time, or if we consider black hole in the space-time, it would wrap this much black space-time or more than this. And so we say that the gravitational force is infinity. Even here, where it is, this here the singularity is warping the black hole, sorry, warping the space-time to infinity, and so the gravity is also infinity here. So this is the thing. And the biggest question now, do they die or not? Yes, some theories say that the black holes die, the black holes extinguish sometimes because of this particle jet, or we can say Hawkeye radiance also. The Hawkeye's radiation and the particle jet is the matter or the energy being extracted from the black hole and thrown towards the two directions or ejected towards the two other directions. And this is actually eating up the black hole, like taking time to eat up it, but it is eating the black hole. And due to this, the black hole's energy reduces. But remember, whenever the black hole is near some object, it will start grabbing it and it starts eating it. And so it's like a human work, and then human releases the energy for working, but human eat and gets the energy. Same happens to the black hole. And black hole eats the object around it and releases the energy like this as a particle jet or Hawkeye radiation. And so if black hole have nothing to eat, the Hawkeye radiation would kill the black hole and nothing would be left there. So this is the end of the video, and here we end up the playlist. The playlist, everything you should know about the black hole, is ended here. And if you enjoyed this video, please put a thumbs up down there and subscribe this channel. Hit the bell icon button, and also stay ready for the next video. Thank you guys for watching this video again.